right, so to simplify here, you want to break it down by looking at each individual section of each fraction. So let's start with the top bit here, y squared minus 4. If I factorize that bit, basically what we want to do is factorize each piece as much as possible, if possible, and then we'll kind of see where we can simplify from there. So you'll see what that looks like after we factorize. So if I factorize y squared minus 4, that's a difference of squares, right? So here the squared term is y squared. So if I break that down into two different brackets, the square root of y squared is y as our first term in each bracket, and then the square root of 4 is 2. And then remember we need 1 plus and 1 minus because that is how we factorize the difference of squares. And so that kind of stays on the top, so I'll keep that on the top up here. Y plus 2, y take away 2, and then following from below, y plus 2 is this factorized as much as possible, so we'll just keep it the same. And then what happens is this y plus 2 will stay in brackets. We don't separate that at all. If this fraction is set up this way, we don't separate that y plus 2. It has to stay together. And since we're multiplying times this other fraction, we can kind of just extend this fraction out here and say that y plus 5 stays in brackets like this on the bottom, and then basically everything on the top is multiplied by 5. You could kind of say multiplied times 5 over here, but we'll just move it just to make it look a little bit nicer. So if you want me to rewrite this so it looks a little bit nicer, you have 5 brackets y plus 2 brackets y minus 2 all over y plus 2 brackets y plus 5. And then we've kind of seen this in class, but you can cancel out anything that matches on the top with anything on the bottom. So since I had a y plus 2 in brackets on the top, I also have a y plus 2 in brackets on the bottom. Those cancel out, and then you're just left with everything else. So 5 brackets y minus 2 all over y plus 5. You don't really need the brackets if you only have one set at the end here. You could add brackets there, but you do not need them. And that would be your answer because there's nothing else on the top that matches the bottom of that fraction. All right. It's a little bit complicated. We'll get into that a little bit later on in the year of why this has to stay in brackets with this, and you don't really need to kind of, you can't really cancel out this y with this y squared because these are separate groups. Just think of factorizing first and then simplifying, and that will give you your answer. So looking at the next question, again, all of these are separate groups. So you can automatically just put them in brackets if you like. And then we want to look at each individual one and see if we can factorize. So this entire first fraction here is already factorized top and bottom. Obviously 3 we cannot do anything with. 2x plus 1, there's no common factor there, there's no squared term, so we're good. But this one, 4x squared minus 1, that is also a difference of squares. 4x squared is a squared term. If I factorize that, the square root of 4x squared to find the first term in each bracket is 2x. And then the square root of 1 would be 1. We need 1 plus and 1 minus because, again, that's how we factorize a difference of squares. And then for our last set of brackets, x minus 2, also factorize as much as possible, so we're done. Let's see, so let's reorganize this. I'll go across the top, so I have 3. I'll just leave it in brackets, and then across the top here, I can combine all of this together into the numerator of my new fraction. So basically, if I'm timesing two fractions together, you know how we multiply top times top. So that will all stay on the top. So we factorize this to be 2x plus 1, brackets 2x minus 1. And then in the denominator, you have all of this. So this will all come together to form our denominator. 2x plus 1 brackets, x minus 2 brackets. Now let's see, does anything match? In the numerator and denominator, yes, these match, so we'll cancel them out. And then let's see what our answer is. So 3 brackets 2x minus 1 all over x minus 2. Again, if you want to leave those in brackets, you can, but You do not have to go ahead and add them for our answer. But that's about it. All right, and here in the next two, we're asked to simplify. So again, what you want to do when you're simplifying an algebraic expression that is written in fraction form, you want to make sure you factorize first. So factorize along the top and factorize along the bottom, and then we will kind of see what we can cancel out from there. So along the top, if I'm factorizing this here, what I'm looking for is a common factor. So I have 12 and 8, the highest common factor there is 4, and with x squared and x, highest common factor would be x. If I divide both terms by 4x, 12 divided by 4 is 3, x squared divide x is just x. Let's see, and then 8x will divide by 4x, it's positive. 8 divided 4 is 2, and then x divided x will go away. So we're factorized along the top, that looks good. Let's see, along the bottom, hopefully you can recognize this is a difference of squares. So we love that. Okay, so square root of 9x squared is 3x. And then 4 we have here, so square root of 4 is 2. I have 1 plus and 1 minus, and look at that, they cancel. So exciting. And everything left over will be our answer. You can put brackets on the bottom if you like. It might just be a good habit to go ahead and do so. And that's it. I guess one thing to keep in mind that might be confusing at first, and again, we will talk about this more later on, but you cannot just cancel 4x and 3x because this on the bottom, it has two terms. Just think of them as maybe married or something that you cannot split apart. Maybe that's not the best metaphor for that, but you cannot split this 3x and minus 2 because they just go together. It's considered something called a binomial, and we'll talk about that later on, but basically just leave it as it is, and these cannot cancel out. So you're finished. That's your answer there. All right, let's look at question D. Let's see. So again, we want to factorize here along the top and then factorize along the bottom and see what we can cancel out. So taking a look, on the top, that would be a difference of squares again. So let's see, the square root of 25a squared would be 5a, and then the square root of 16b squared would be 4b. So two sets of brackets, right? The first term comes first, 5a and 5a. Second term comes second, 4b, 4b, 1 plus, 1 minus. That's how you factor a difference of squares. We're pros by now. And then let's see, on the bottom, this is just an algebraic expression with a common factor. So we're looking for the common factor. The common factor of 10 and 8 would be 2. And then let's see, only one term has a, so we will not factorize out the a, but we will factorize out b. Only b to the power of 1. Remember, we always want to factorize out the lowest power. So we're going to factorize out 2b, which basically means I'm going to take that expression here and divide everything by 2b. Hopefully you can do that kind of in your head, but if not, let's write it out. 10 divide 2 is 5. A divide no a would just leave you with a. B divide b goes away. And then bring down the minus. 8 divide 2 is 4. B squared divided by b, imagine there's b to the invisible 1 power, would be b. So you're left with this expression in brackets, right? Because we factorized out that 2b. And magic, as usual, these expressions cancel on top and bottom. And then again, we just leave everything else in our answer. I just pulled this over here, pulled this over here. The only thing is, again, remember, you cannot cancel this b with this b because this is considered a group that you cannot split apart. So this would be your answer as simple as possible.